me. Kommt jetzt gerade. Also wir sind jetzt.
Also 30 Sekunden geht es los.
In 30 Sekunden.
Also dann kommt aber zuerst das Video.
Nein, das kommt zuerst mal das Video, genau. Also du musst sagen, 3, 2, 1. Genau, du musst anhand vom Video sagen.
I guess I'll film it.
Can you look on LinkedIn?
Also 20 Sekunden.
Yeah. I look at LinkedIn. I have the link here.
I gotta go now. Okay, see ya.
'Good afternoon, everyone, and welcome to the Swiss Autonomous Valley livestream event. And it's really wonderful that you're all joining us virtually. Thank you so much. I'm Tani König, and I'm very pleased to guide you throughout the next hour. And now we got a few opening remarks by Daniel Gerber. He's the Vice President of the Board of the Swiss Autonomous Valley.
2020 was a special year for all of us, but it was also the first year for Swiss Autonomous Valley. We could learn more about your needs, grow the community, and develop a joint strategy for 2021. We will focus on further developing a virtual test environment, combining high-definition reality capturing within a simulation environment, together with scenarios that are relevant from a regulatory perspective. What we are creating is unique, and it needs the whole community. It needs you to make this happen. Now hear more details from our team and our experts. Enjoy the stream and happy holidays to all of you.
Very much, Daniel. We now have Tobias Pfohr. He's the Managing Director of the Swiss Autonomous Valley with us. And Tobias, after seeing this video by Daniel, I must assume that you're very excited as well.
I am. Thank you very much, and also welcome from our side to you, and thank you for hosting our streaming event. I'm very excited because we have great experts here today, and I'm very excited to hear from them and also look with you in the community how we can develop the Swiss Autonomous Valley next year and everything that is to come.
Great. Thank you very much, Tobias, for having us. So today's event consists of 3 short blocks on several topics, and we start with the application of autonomous systems. Then we continue with the creation of digital realities, and we'll end with connecting real spaces with digital information. And each block consists of a Q&A with one of our experts. You can see 2 of them here with us. And you can, of course, send in your questions that you have to the experts via the comment section on YouTube. So just right next to where you're watching the video, you can comment, send in your questions that you have, and we'll try to integrate them. And we'll end the event with a short panel discussion with all of our guests. And if you want to share your thoughts on the event, on what you've heard here, then please do so on social media with the hashtag Swiss Autonomous Valley, and you can tag us on LinkedIn and Twitter. So we'll now continue with the first block on the applications. And we have Swiss Post with us. Swiss Post has tested a few autonomous systems, such as delivery on the ground with their hospital robots, or robots delivering parcels at EPFL, and up in the air with their drones delivering blood samples. And while you're thinking about your questions, we'll show you a few impressions of how this looks like. I'm now joined by Andrea Marazzo. He's the head of the autonomous delivery at Swiss Post, amongst many other functions that he has there, and who is here to answer our questions. Hi, Andrea.
Hi, Tanya. Thank you very much for having me.
Yeah, thanks for being with us. So after watching this video, I wonder, in the future, won't we see any postmen or postwomen anymore?
It's a question we get very often, and basic answer is no. We will still have a lot of postmen running around just because the efficiency at where those guys are able to work is something which is basically unreachable for those systems at the moment. So
at
it will stay the same for the next decade or so.
Okay, good. And so many out there might be relieved. What further projects are in the pipeline at Swiss Post?
Well, we are working on many sides, always, of course, taking into account the autonomous systems. And at the moment, we are focusing very much on ground transport, so with autonomous vehicles which have wheels. One of them is the one you've seen in the first video with the hospital robots. That's really where we are pushing at the moment and entering into the market. And the second one with the EPFL case, the Campus case you have seen, there also the next step would be to take these vehicles out on the roads and go into real parcel delivery in the next future.
Okay, so you mentioned those robots in the hospitals, which we also saw. How much cost can you reduce by using those?
It's a good question. Basically, it very much depends on how much do you integrate these vehicles in your daily processes. So it really depends on how far does a hospital goes within the integration, or if it's just kind of a dumb autonomous vehicle which goes from A to B, or if it is really integrated into processes. But we have projects which the manufacturer did in the States with hospitals there, and they were able to save up to 50% of costs in those logistics tasks. So the potential is big. It really depends on the integration on the hospital side.
Okay. Then looking at drones, what is the biggest challenge there when transporting?
Basically, we have two challenges. One of it is, of course, the part about regulations. So there it is, still we have to find a spot and the definition how to operate in the air, because, of course, there are many other airspace participants like Rega helicopters, military jets, and of course all the other aviation, and we have to define the rules how we integrate the manned with the unmanned aviation. So that's one of the challenges. And on the other hand, what is very important to see is at the moment we are just we do the automation of the transportation. So drone flying from A to B, but to be able to enhance these things, we need to be able to not just automate transport, but really the process from giving up a parcel to receiving a parcel. So it is much more of being able to have a holistic sight on the whole supply chain, and not only about the one leg which is done by drone or not.
I see. And you also mentioned before regulation. We'll talk a little bit more about that in our panel later on. But another question I have for you, in 2019, you had two incidents with your drones, one in January, one in May, one of them being a drone landing on the Lake of Zurich, and the second incident being one of your drones crashing in the forest in Zurich. So how did you experience that, and what have you changed since then?
Well, the experience was pretty special. So on the first one, the one where the drone landed basically on the parachute, in the beginning we were very happy because we had the proof that all the safety systems and also the process we went through with FOCA, so the Federal Office of Civil Aviation, worked. It's just afterwards when we went through the GPS locations that we realized that basically we aren't landing on ground, but there was water. So it became clear that the drone basically sank to the bottom of the lake, and we had to bring it back up. So this was the biggest challenge, was really how do we go through this process and be able to bring it up again. And on the second one, about the experience, I was at the presentation at the customer when my phone rang and I heard the guy from the operations telling me code black, which means, okay, we had a drone crash, and it was the first time I really left pretty fast a meeting with a customer because I had to understand what happened. But having all the process done in January for the first time, at least we were a bit used to whom you have to call, which is the process to inform FOCA, to inform the police, and so on. So we were a bit more in the process. And regarding what we have changed, it is a lot has been done on side of just making the errors we did go away, or kind of building in some more layers so that it doesn't happen again. For example, at the second crash, one of the cables just broke, and what we did is we shielded it with metal so that this cannot happen anymore. But a lot of it is also in we founded an expert panel for these events, and they went through all of our changes we've made, and it is available on our homepage. So there is a whole report where you can read everything, what we've changed and how they feel about it, what is very important.
Okay, good. So you can check that report out on the website of the Swiss Post.
Correct.
Thank you very much, Andrea. So we move on to our second block on the creation of digital realities, and we are joined by Hexagon. They are creating a digital twin of our environment, and their 3D worlds help autonomous systems to navigate the real world. But let's see it for ourselves while you think about some questions for our expert here. So here are some of the impressions of how Hexagon creates a virtual reality.
Volumes. The data is uploaded into the platform and the processing starts immediately. From images to point clouds and from point clouds to 3D models. The Hexagon Digital Reality Platform is a cloud-based platform that allows processing and visualization of these huge reality data volumes. The data is uploaded into the platform and the processing starts immediately. From images to point clouds and from point clouds to 3D models. The outcome of the Hexagon Digital Reality Platform is the perfect digital twin. A 3D model of a city, for example, that has implementations into industries like architecture or construction or even autonomous systems. Some examples of the use of these 3D models is, for example, robotaxis for delivering within hospitals or within a campus like the ETH Honkeberg campus. The added value of this outcome of the 3D model that comes out of the Hexagon Digital Reality is that it can later be exported into simulation software like the NVIDIA Isaac software and replace the artificial environment with a 3D model that perfectly replicates the real world. Thanks to Hexagon Digital Reality Platform, we enable teams in autonomous systems to develop and deploy faster.
I'm joined by Pascal Struppler. He's the product manager of Hexagon's digital reality. He was not in the video that you saw right now, but we'll show another one right after. But first, I'd like to start with one question, Pascal. How exact are the visualizations that you do?
Well, it really depends on the sensor, but in general, the core measurement instrument is a LiDAR scanner in all the sensors. So the airborne scanners, the terrestrial scanners, and there we really measure in sub-centimeter range. So geometrically, those scans really are as accurate as you can imagine currently with the current technology. Then, of course, we have additionally, we take pictures and we use those as textures. And in the video that you've just seen here, this is actually created from an airplane. So we have a sensor in the airplane flying over the site, and there the resolution goes down to 3 centimeters per pixel.
Okay, thank you very much, Pascal. Let me just check if we have the other video we'd like to show. Okay, director says yes, so here it is.
Wir von der Swisscom Digital Business Unit sind überzeugt, dass autonome Drohnen und Roboter in Zukunft eine wichtige Rolle spielen werden und wir darum 3D-Welten brauchen, um realitätsnah Tests orts- und zeitunabhängig zu simulieren. Darum sind wir heute hier an der ETH Hönckenberg, wo wir im Auftrag vom Autonomous Valley das Ganze vermessen.
Das Ziel dieser Aufnahmen heute ist, ein möglichst detailliert getreues 3D-Modell vom ETH Campus aufzunehmen. Wir nehmen die 3D-Umgebung auf mit verschiedensten Leica Reality Capture Sensoren. Zum einen ist das der Pegasus Ultimate 2, das ist ein Sensor auf einem Auto, dann ein Backpack, also ein Rucksack und auch ein Handheldscanner neben den Aufnahmen aus der Luft. Nach der Aufnahme folgt eigentlich die Nachbearbeitung und das Zusammensetzen vom ganzen Areal in ein 3D-Modell.
Aus den gewonnenen Daten werden wir jetzt einen Digital Twin von der ETH Hönckenberg erstellen. Zusammen mit Startups wird es so möglich sein, innerhalb dieser 3D-Welt komplexe autonome Cases zu testen. So wird es in Zukunft beispielsweise möglich sein, dass bei einem medizinischen Notfall eine Drohne einen Defibrillator bringt oder auch, dass ein Sandwich direkt in einen Hörsaal geliefert wird. Was die Tests noch alles bringen, das wissen wir jetzt noch nicht, aber wir freuen uns sehr darauf.
Just a quick reminder that you can send in your questions that you have to Pascal Strubler via the comment section on YouTube, and we'd love to take those in. But now, Pascal, can you quickly comment on the video that we just saw as it was in German?
Swiss German, actually, even harder. So, yeah, what we basically did during that venture was to capture ETH Hönckenberg, so the campus from both the air but also from ground, and this with several sensors. So what we try to do is really to capture reality as a whole, so with the best possible coverage. From the air, we actually, as I mentioned before, we were flying with an airplane with a Leica Citymapper sensor, and the data set you saw in the beginning was actually the output of that scanning. So this is just based from the air. But then we are also scanning from ground to really get details from ground, and of course also scanning the insides of buildings. And finally, our aim is really to combine all of this and fuse this data to have a complete model of whole Hönckenberg.
Okay, so and what interface can we expect?
So this is where the challenge starts, right? I think with simulation and reality capture, we really have two different worlds. In simulation, you model an environment completely manually, and you end up with a really visually nice design of maybe a real environment, but basically it's hand modeled after an environment. On the other hand, with reality capture, you capture reality, but in the end it's probably not necessarily visually the best way to simulate things, especially if you want to simulate computer vision and you need reflections and transparency, things like that. And so what we're building within Swiss Autonomous Valley is basically exactly this interface and the additional intelligence, we call it semantic mapping, that needs to be done to add information, and with that provides, for example, material properties and basically connect these two worlds together.
Okay. And when can we expect a version which can be used then for simulations you're doing?
So I really hope first half of next year. So this is currently in development, and we're looking forward to work with everybody here to release this data, basically.
Very nice. First half of the year. Yeah, let me see if I have one more with... yeah, maybe the biggest differences between a digital twin and the real world.
So what we capture is, with the LiDAR, we basically get the geometry of the real world. And of course, with the photos that are captured in parallel, we get, so to say, the texture. Now, the biggest difference, I would say, is that material properties or surface properties is something we're not capturing yet. Yeah. So basically seeing something as a window with certain transparency, or a flat floor that actually has some reflections, this is something that's not possible yet. And we're currently looking into to add this semantic information to at least guess what the material properties are. I think this is really the biggest difference.
Yeah. Thank you very much, Pascal. We have one question from the community, so I'm going to read it to you. What's the strategy of Hexagon Digital Reality for autonomous ground vehicles, HD maps, only point cloud representation, and how do you manage the changes to the maps? What are the limitations on scaling?
There's a lot of questions here.
Yeah, in one.
So maybe the most important goal of HXDR is to be a cloud platform for reality capture. So what we aim to do is really a scalable solution, meaning there should not be any manual processes involved. So everything we developed should run autonomously. So the whole creation from reality capture then to really the deliverable that can be used in a simulation should be autonomously created. Having said that, really the end result that comes out of HXDR should be something that can be used in simulation. So that means not just a mesh, so the geometrical structure and the texture of it, but really, as I already mentioned, material properties such that in the end really also computer vision algorithms can be trained based on the visuals.
Okay, good. Thank you very much. Is there anything else you want to ask to one of those many questions in one question?
I mean, limitations.
Oh, there's another one actually. So which industries will take more advantage of the digital twins?
This is a very broad question. I think in general, a reality capture is, for us, another step towards digitization. Digitization happens everywhere. It happens with documents not being on paper anymore, but really just Word documents, or even in chats. I think what we're doing with reality capturing is really the same thing, but for environments. So in the construction, for example, if you have a digital twin of something that has just been scanned yesterday, a worker doesn't necessarily need to go to the construction site anymore to check on things or measure things. He can do that in the digital reality. So I think there's a wide variety of use cases for digital twins. It's really the digitization for 3D.
Will make many industries easier to work on. I think we have one more question. Cloud or desktop digital platforms, what is foreseen to be mostly adopted in Switzerland?
I think the future is cloud, but especially for simulation again, maybe the use case is another one. You need powerful computers for that, and you can run them in the cloud, but I think currently, with all the things you simulate, you're probably better off with desktop software.
Great, thank you very much, Pascal. So we move on to our next block on the topic of connecting real spaces with digital information. And for that, I'm joined by Mark Polyfice. He's joining us virtually. He's the Director of Science at Microsoft, Professor and Head of the Institute for Visual Computing of the Department of Computer Science at ETH Zurich. Mark, can you hear me? You can unmute if you want, just to say hi. Mark? And maybe before we unmute Mark, in the meantime, let's look at one of the videos to see what his work consists of. So for
robots
Mark,
are increasingly a
if you have
part
any
of our daily lives, at
because
home
we
and
have
in the
to
workplace.
arrange a bit.
Mixed reality allows us to
Because
blend
actually the
information
questions
from the digital world
Weil
into the
mit
physical.
Simulation
At
was
Microsoft,
interesting.
we have been working to bridge the gap between robots and humans by leveraging mixed realities. Azure Spatial Anchors is
Weet
a
je me
mixed
genau
reality
wie dat
cloud
ziet?
service that uses computer vision to localize devices to distinct places in the environment, persistently over time. These spatial anchors can be shared between Android, iOS, and HoloLens devices to anchor holographic
sind, glaube ich,
and
nicht von
digital
YouTube
content to the real world, or to give all
Hello, can you
agents
hear me?
a common coordinate system.
We are excited to announce that we have extended Azure
Yes.
Spatial Anchors to enable robots
can hear
to
me.
localize to the same anchors, allowing them to share a coordinate system and spatial data with mixed reality devices and each other. This allows
I'm watching it
robots
on YouTube.
to
I
have
brought down the
greater
sound
autonomy
now on the video.
by accessing contextual information from other
Is there a
devices
delay
and
between
from
the
mixed reality cloud services.
In addition, co-localization with mixed reality offers many new possibilities for human-robot interaction by giving people insights into the robot's state and intentions and enabling natural modes of interaction through hand tracking and gaze tracking. The robot needs to be equipped with a calibrated camera and its own pose estimation system in order to create and query Azure Spatial Anchors. For example, this can be done through a visual SLAM algorithm or by having a camera mounted on a robot navigating with LiDAR.
This is a special research SDK release targeting Ubuntu 18.04 and 20.04. And we provide a ROS1 wrapper for easy integration into your robotics projects. Please follow the link here for more information about the SDK and how to get started using Azure Spatial Anchors on your robot.
Okay, I'm now joined by Mark Polyfice. Hi, Mark.
Hello.
Hi.
Here, at least virtually.
Yeah, we already heard you before a little bit in the video, but now it's the right time to speak. Maybe, do you want to quickly comment a bit on what we just saw?
Yes, so essentially this is really something that, you know, we have a service that we developed that's called Azure Spatial Anchors, which is a service that allows to connect reality, you know, digital information to reality. So what you could see in particular, this is really a service that we've developed for mixed reality for devices like this one here, like a HoloLens device. So to enable to essentially place information, digital information in the real world, and then be able to find it back or to share it with other people and so on. What we've now been focusing on is also bring that to robots, as then people and robots and so on can all connect to the digital information, the points of interest, all of the kind of digital assets that relate to a space, can connect that to you know, to the real space, connect robots and then humans with the mixed reality devices. All of this can now be connected also back to reality, and so in a sense it connects very nicely also to the previous presentation from Leica, reality capture. As you know, it allows to have all of these different concepts connected, go from reality to captured reality, do simulations there potentially, enable autonomous robots to learn skills, and then bring it back to actual reality and have the robots move around there in a particular map, in a particular space. So all of this comes together nicely.
Okay, and what are the biggest challenges when doing that, when connecting real spaces with digital information?
Well, some of the challenges really have to do with the fact that reality is not, a static thing. It's not something that you can go and scan once and then be done forever with it. Real environments, will also, the appearance depends on illumination, depends on the seasons, for example, et cetera. And so it's actually a challenge to be able to make all of this work also across those variations, across those changes. People walk around, there's cars that move around. So the environment changes continuously, and building systems that can somehow cope with that, both for the autonomous platforms as well as actually our systems that allow to relocalize in those spaces, they need to recognize the space independently of those changes.
Okay. And what are the questions that you are at the moment mostly asking yourself during your work?
So there's many questions, but let's say one that's really interesting is we can start see how all of this comes together. But there's going to be quite some work in the years ahead, and I'm really excited about the Autonomous Valley project here to really to bring all those pieces together and make essentially all of this work seamlessly together. So we have reality, we can capture reality, we have mixed reality to enable people to interact in the real world, also with the digital information. We have these autonomous agents that can do a number of tasks. You want these autonomous agents to work well together with people, to have access, to be able to learn those skills from. So all of these concepts somehow fit together, but really making all of that work, that's an exciting, adventure in the coming years. And so that's really one of the big questions of how to make all of this work together.
Okay. And what do you need still? Because you said this, sometimes to make sure it works. Is there something that at the moment you think this is needed that we get a bit further?
Well, I think in terms of autonomy, we're still at the beginning. So I think we need to, to have an autonomous system work in a real space. I think we need two things. One is we need the autonomous system to be able to, in a sense, behave, to have a number of capabilities and skills in that environment. That's really where reality capture comes in, where simulation comes in, where you can essentially build a number of example worlds. You can have those systems learn how to behave in there and so on. And then you also need an actual copy of the real world, or you need this digital representation of the real world that the autonomous system can essentially, that connects essentially the digital information to the real, to the real world, so that the robot has essentially a plan or an understanding, as we heard before, semantics, etc., has an understanding of the actual world that it has to operate in. And so it has both some generic skills that it learned in simulation, in training, and so on, and then it has actual points of interest. It has specific tasks that need to be specifically executed in the space where the robot actually moves around in.
Mark, I think we have a few snippets, video snippets. No? Okay. No, okay, so thank you very much, Mark. We'll actually continue with our panel. We like to zoom out a bit of the micro view to a broader perspective. So please stay with us, and we open it back up. We have our speakers back that you already got to know before. So you can also, I think our speakers, they don't hear you, Mark. I can hear you. But nevertheless, if you want to comment on anything that they are saying, just let me know. And maybe I'll start with the question, what is still needed for autonomous systems to be able to orient themselves? And I'm looking at you, Pascal, so you can start.
I think actually that's a question for Mark, but I think it's clear if for orientation of autonomous systems, you need to be aware of the environment, and if you already have a digital copy, at least that helps, especially if we talk about spatial anchoring, I guess. Yeah.
Okay, Mark. So, do you want to add anything to that?
I mean, not immediately. No, I think it's fine.
Okay, good. Then, Mark, maybe to you, how can we close, or actually this one is to Pascal now, how can we close the sim virtual to the real world gap? What are the challenges that we need to overcome there?
So the challenges here is, I think, for the simulation to be as accurate as possible to the real environment, because the goal is at one point to save time and resources with simulation. So test your system as much as possible in the digital twin before you go actually on location, and you invest a lot of time putting your robot there. So it needs to be really a digital copy, an accurate copy, which means we need to improve the geometrical accuracy. I think there we're good. Texturing is also good. And then it really depends on the systems. What are the sensors that need to be simulated? If it's LiDAR sensors, geometrical accuracy is enough. You don't necessarily need textures for it. But then again, if you have a system which navigates mainly with cameras, you need to actually simulate what a camera sees, and with that basically the complete visual quality of what you know outdoors and what you know when you move around indoors, and you have reflecting windows, you have mirrors. You need to simulate all that, and I think there it gets challenging. And in general, the closer we get to reality visually, but also geometrically in a simulation, the better it is afterwards, or the closer the results are afterwards with taking the robot into the reality.
Is there anything, Mark, you would like to add to what you just heard?
No, it's good.
Okay. And what kind of challenges does this create for regulators?
That's the question for you, I guess.
Okay.
Well, I'm obviously not the regulator, but during all the discussions and all the experience we gathered together with them, with drones and delivery robots and so on, I think one of the biggest challenge which we are facing also within the Swiss Autonomous Valley, but also the regulator, is all of us, we need to learn how we take the steps towards getting the ability to approve a system based on a framework. At the moment, it is often we are discussing together with the regulator about one specific operation. So let's take drones. If you get an approval for a drone operation, the one in Lugano or the one in Zurich, then we have filed a document to FOCA, which exactly describes what's happening there. So you make a whole risk analysis and simulation of it just for this case. And this, of course, isn't scalable. So the biggest challenge here for all of us is to find and define a framework on which everyone agrees, to see which are the steps you have to take to have, let's say, scenarios which you have to be able to simulate in a digital environment, but then also take the digital to the physical site, have a vehicle there and perform the same operations it performed in the digital one, in the physical one, and prove that everything is working the same way. So this kind of a big chunk of work still to do in defining what steps you have to take in the next time.
So do you basically need to create specific scenarios, virtual scenarios that convince regulators?
Sort of, yeah. So first of all, it is to get an understanding of what do they expect. Because for classical aviation or also for classical vehicles, they have the definition what you have to prove as a manufacturer so that your vehicle gets approved. Let's take a vehicle manufacturer. He knows I have to drive or simulate 100 million of driven kilometers in these and that scenarios, and as long as I stick in this framework, I know what I have to do. And for the autonomous world, this doesn't exist yet. And that's basically what we with Autonomous Valley are also trying to do, is getting an understanding of what do we have to set as a framework, and could we help together with the regulators define these scenarios so that everyone knows a little bit more what the frame is?
So a lot of unknown things there. Yeah.
It's innovation. That's part of the game.
We have a question from the community. What about drones applications in Switzerland, drone delivery, telecom, 5G inspections, smart and precision agriculture, emergency response? Who wants to say something?
I can
go ahead.
take it over. So, as of course, there are several different applications already having in Switzerland, ours with basically logistics, so transporting blood samples, but there are many, many others. Just to name one, there is a company which uses drones for generating a weather forecast. So they have a drone which is able to fly hundreds or thousands of meters up in the air and makes wind measurements and temperature measurements. And with these informations, they are able to have a much higher and more detailed weather prediction than we have today. So that is very interesting, and there are many other, also in sensing, there are many other drone cases which are happening. And maybe there were other questions, but...
No, that's just another one. But let me, as we have Tobias Pforr still here with us, maybe would you like to say something?
Right. So the question is also like with different applications and like in the creation of Autonomous Valley, we've been discussing a lot about like what should we focus on, because there's a huge variety to pick from. But we also said, let's start at the minimal viable product. Let's start to identify like the critical path that we actually need from all the different parties. We have the operators of autonomous systems, we have the developers, we have the regulators, and all those need to find the right intersection. And what we basically identified so far is that we have missions that can be carried out either on the ground or in the air from point A to point B, or we have a clearly defined path. And those two missions actually, they can represent a lot of different applications. That could be picking up the mail from a mailbox in the middle of the night while the streets are empty, while at the same time you could also have a precise path to clean a road in the night to make it spick and span for the next day. And the same also then applies for precision agriculture. We have clearly defined things that you want to do, but we first want to see how can we actually get the basics, how can we also pick out the challenge and maybe invite like a set of 5 teams to meet those challenges, to have regulatory relevant scenarios then in the space, so that we can also give the regulator proof that whatever we do in the virtual world kind of reflects back to the reality, to also like help the whole ecosystem as at large, to really like learn the digital reality and the digitalization of that space as a tool.
Thank you very much, Tobias. Mark, I'm turning to you. Anything you would like to add?
I think compared to, yes, related to some of the previous questions, I think, you know, the emergency response topic that was brought up earlier, I think is really interesting. I think that's where, you know, I think what's really interesting in terms of autonomy is to really have a combination of autonomous systems also teaming up with people, having both drones fly over, having some robots get into dangerous areas, and then also have the people, you know, the emergency responders, the first responders, be able to share this kind of common, like the sensing of all the different platforms be integrated and be brought together. I think there's really interesting stuff to be done in that space. Maybe also briefly, somebody was asking about the possibility to do crowdsourcing. That's also certainly, you know, for reality capture. I think that's something that's also very complementary to some of the high-end scanning. In particular with HoloLens or with mobile phones, you can actually also capture, not at the same quality necessarily today as you can do with, you know, with high-end scanning devices that Leica is producing, for example, or Hexagon. But if you look at a HoloLens device or any mobile robot or autonomous robot needs just to operate, needs to map its environment. And so figuring out how those robots, those devices, those mixed reality devices and so on, how they can all help at complementing the maps, at updating the maps, also autonomous vehicles driving around and so on. They can also all really help. And I think also figuring out there how to get the best complement between high-end reality capture and then complement of crowd mapping capabilities. I think, to extend the map and update the map, I think there's a lot of really interesting stuff to be done there.
Thank you, Mark. And you also already addressed one of the questions from the community. I'm going to throw the question into our panel here on location, which is 3D crowdsourcing. How would you compare capturing the environment by high-end equipment mounted on aircrafts versus swarms of vehicles operate every day on roads?
I can take that, I guess. Definitely very interesting, and I feel like somewhere we're going in the future. I mean, we're already working on that by fusing data from different sensors, even if they're high-end. It's important to basically make our first learnings, and if the sensors are high-end, of course, it simplifies the problem. But once we solve that problem, we can really go down and add additional sensors, be it iPhone LiDAR cameras, autonomous cars that will capture the whole environment 1,000 times per day at every place. So I think this is a very interesting use case, and I also feel that data fusion in the sense is somewhere very important for that.
Mm-hmm. And we have another question from the community. For the autonomous delivery, what is the strategy to keep track and remotely manage all the robots and drones in operation? Yeah.
I think that addresses pretty much Swiss Post. So at the moment, of course, we have all those operations, drones, delivery robots, classical autonomous vehicles. They have their own remote operating center, which means each of the technologies are operated on their own, and there we already have the possibility to remotely change something, settings. With the drones we are able to hold the drone while she is in flight. If we see that, for example, a Rega helicopter is approaching the path we are taking, or for the indoor robots, also the hospital robots, we are able, if the robot gets stuck somehow, to access to the robot sensors so that we see, okay, what's the problem, and then send him another way. Of course, in midterm, the idea would be to have kind of one center where all the autonomous system will be managed as a holistic way. But that's something we are still working on, because first now we have to put together each piece so that we will be able in mid or long term to put them together and really have an autonomous delivery system, kind of an autonomous supply chain, and have this operation for all of them. So it's something which is on our sheet, on our task sheet, but it's not something we are able to solve short term.
Okay, thank you, Andrea. Then there's another one. Would an effective handling of a soup of points or a mesh not require semantic understanding? Pascal.
Soup of points, I like that. Definitely, this is required. Even already for meshing, it really depends if you're meshing a soup of points which which represents a tree, or if it's a wall. So this is something we're already doing, and as I mentioned, for going further into simulation, where you also need to understand the material and the surface properties, this gets even more important to understand. Is this something that reflects light? Is it something that is even transparent maybe, and you just captured a couple of points? This is pretty much what we're already doing, and it's very important.
Okay. Then I have a question to all of you, which is why are you participating in the Swiss Autonomous Valley? What is the main reason? Why should others participate as well, as a first one? And then what is still needed the Swiss Autonomous Valley to accelerate your cause. So shall we start with Mark?
Sure. I think for us it's really interesting. As I don't think anybody can solve this whole problem, just by yourself or so. So I think it's really important to bring different elements together. The reality capture, some AI capabilities, some simulation capabilities, some connecting back to reality. All of these elements need to be brought together to get to success here in a really challenging problem. And so I think that's really what you're looking for, is figuring out how the things we work on can connect to what the partners here are working on. And so that's why we're excited to participate.
Great, thank you, Andrea.
It was hard
to understand,
I have no idea what Mark said, so maybe I will repeat what he said.
That's okay.
So from our side, one very important point is, during all these years we were dealing with autonomous vehicles, we just realized it's not a one-man show. So you won't be able to do it on your own and just be
basically what Mark said.
Okay, perfect. So same as Mark said.
Okay, but maybe to the other point, what do you think is still needed to accelerate your cause? I think Mark didn't really respond to that.
I think one of the most important points is time. Mm-hmm. So we just started this year, and we starting to build up momentum and getting some traction. So it really is, first of all, now bunching together, working together, get these simulations, these ideas we are having together done, and work on it. So, and then of course see where does it leads, and then we will see whether there is something else needed or not. But at the moment, for me, it's too soon to say we need a little bit more of this or that, just because we have put everything together. Now we have to prove that it works like that, and then we'll go on.
Okay, very nice. Pascal?
I really like within Swiss Autonomous Valley that it's really an end-to-end workflow. So you start with capturing reality, you put it into simulation, you simulate your robots, and you bring them back. It's like a closed cycle. And for me, I think very important, or I think simulation is really the key for robotics. If we really want to make robotic systems safe, we need to scale up simulation, and we can only do that once we verify that basically the simulation we do corresponds to the reality. Only once you can show that this is not just hand modeled, but really a digital twin, you can say, well, whatever happens in simulation is 99% will happen in reality as well. And then you can scale up, you can vary little differences in the simulation, you can test way more than you would be able to test in real life. And for us, I think this connection, reality capture to simulation, really doesn't exist yet. And in general, for Hexagon, everything that's not there yet and that needs a solution is of course, be worth to be tackled.
Okay, great. I see there's another question from the community, so I'm just going to take it in. How do you deal with intellectual property of the participants in Swiss Autonomous Valley? Tobias?
I'll take that question gladly, because I've had it actually right from the very first moment where we had the core team meeting, where actually IBM and Microsoft were raising that exact question, and I had to say, I don't know yet, because let's see like where we have different touch points. Let's treat the whole space with a safe space, so that we can share things with each other, because we need to identify the interfaces between the different companies. We need to identify the interfaces in the whole ecosystem, and then also know what information do we actually have to share, and how do we make sure that we can like read the different spaces. So for now, it's all actually in a gentleman's and ladies agreement that we work together. The companies themselves, they keep their intellectual property, and we work in the way that they allow Autonomous Valley and the partnering companies, the members, to use that information. But we yet have to define like what different elements we give out. How do we include the developers? How do we include the regulator? How do we get all the scenarios on board? So we'll tackle that when the question comes up, and then find also the right agreement. But for us, the key is to really to move forward and to not get stuck in trying to find a framework that a couple months later will hinder us on pushing innovation forward.
Okay, thank you very much, Tobias. I think I see you bending your head, right? And as well as Mark, anything to add on this? No? Okay, good. Then thank you very much to our panelists, our speakers, Mark Polyphais, Andrea Marazzo, and Pascal Struppler. We are at the end already of our panel. Maybe a question to you, Tobias. Maybe your key takeaways from this, and then a short look at what we can expect in 2021.
So first of all, I'm blown away by all the details that come together, and I like the point, the wording, a soup of points, and for me actually it is quite of a soup. Like we're cooking a dish together where we don't yet know what comes out of it. We have different flavors. We might miss something. We have to identify that, but we have a lot of ingredients. We have a lot of chefs actually that have to make a soup together, but in the end, our guest has to like it. So we always need to look forward with the application, with the business in mind, to really also see like where is the interface also with the intersection also with society at large. How do we add benefits to that? How do we create value? And that's what I like about that. It's a soup. It's an ecosystem. And to your question, what is also needed? We need you. We need the community to be part of that. We need fresh ingredients, we need the thoughts, we need ideas, we need people that come with spoons, we need people that come with bowls that dig in and that enjoy it, and that also give feedback. I mean, the last 2 years that we've been working on this idea, we have gotten so much feedback, and we had to pick and choose and find the right way, find the right recipe to move forward. And there's plenty of things still to be answered next year.
I love it. I know. Now I'm getting hungry, you know, hungry for more. How can people reach you then?
Right. So people can reach us through autonomous.swiss. That's probably the easiest way, where we also have our team members on board. Yeah, they can contact us through LinkedIn, through Twitter, through emails.
Anything specific that they can look out for in the next year?
Right. So what is on the menu for next year? We've been working a lot this year. We've put together a very strong board, people that have our backs, that also come with a good foresight and also the resources of their companies. And we're actually planning to have Autonomous Days next year in about May, June, where we want to host the event at Höngerberg and combine like the reality, or the two realities, the digital and the real. And yeah, hopefully already then invite people to be part of the digital reality, to test their systems. We're working also on the concept of a competition, where we want to define missions, where we want to have regulation, be part of that competition, and then have teams also compete and win different prizes. That all is in the making, and yeah, to the ingredients, we actually need you in the community. We need you to join. We need more resources, and we need more energy to push it next year.
Great, thank you very much, Tobias. So you heard it. You can look out for these events. Come with your spoons and your ingredients. And with this, we're at the end of today's event. Thank you very much for joining us today. Don't forget to share your thoughts if you want on LinkedIn and Twitter with the hashtag Swiss Autonomous Valley. I would like to thank the Swisscom Dreamstream team that is behind the scenes, making sure that you can watch this. I would like to thank Caroline from Hexagon for organizing, and everyone else who made this possible, and of course all of our experts, as well as our virtual guest Mark out there. Thank you very much. We look forward to seeing you next year again. Enjoy the holiday season. Thank you very much and goodbye.